Okay, hi guys, Mr. Rocco again. This is the second video this week. I made one on latitude. Now we're going to talk about longitude. So longitude, this is the definition, describes your location. Again, it's a grid system. This time instead of north-south, it's east or west. And instead of the equator as the reference line, we use the prime meridian. The prime meridian is 0 degrees longitude. Longitude is twice the number of degrees as latitude. Remember, latitude using Polaris goes from 0 to 90. Longitude goes from 0 to 180, half the Earth, right? If you picture the Earth looking from above, right, top down, making a circle. Circle's 360, so you cut a circle in half, right? Half of 360 is 180. Latitude lines, remember, are parallel. They stay the same distance apart. They never get closer, further apart. They're equal distant. Longitude lines, that's different. Longitude lines are like lines on a basketball. They kind of go with the curvature of the object they're on, in this case, the Earth. And so they don't stay the same distance. They actually get closer as you get to the top and the bottom, the poles. They're the furthest apart at the middle, the equator. And so they're not called parallels, they're called meridians, right? Which makes sense because if you know longitude, the first line, the reference is called the prime, right? Prime meaning first, meridian. So all other lines are called meridians. Longitude lines, again, run from North Pole to South Pole, top to bottom. And again, 0 degrees longitude is called the prime meridian, which right now runs through Greenwich, England. Although it hasn't always run through Greenwich. It had one time run through the United States, I believe New York City, the prime meridian at one time. It's also run through China at other times way back in history. The prime meridian's been in Greenwich, England since the late 1800s. So I have this little bit of info down here. At an international convention called together by U.S. President at that time, Chester Arthur, in 1884, representatives from 25 countries agreed to pick a single standard meridian. They chose the meridian passing through the Royal Observatory, which is in Greenwich, England. So Chester A. Arthur called together this group, and 25 countries got together in the late 1800s, 1884, and that's where they decided to move the prime meridian. I forget where it was before that, but anyway, that's where it's been since the late 1800s. It's been through Greenwich, England. This is, and I've never been, maybe some of you have, but if you visit England and you can actually go to the Royal Observatory and they have a piece of paper up here marking it. It says the prime meridian of the world, and there's basically the line separating the east hemisphere from the west hemisphere. So it's right there. You can see there's a bunch of people, reflection in the glass there, taking pictures. Very, very big tourist attraction. They actually have a laser. So the door was down here. This is taken from further away. So if you go above that piece of paper, up here at the peak of the roof of that Royal Observatory, there's a laser beam that actually shoots out, that marks the east from the west hemisphere, projecting to show you where the prime meridian is. So it's kind of cool. And this is actually a Google map I pulled up to see where it is in reference to other famous attractions. So the Big Ben, right, the big clock is over here to the west of the observatory. The observatory is right over here along the Thames River, which kind of snakes like this. And so not too far away. It's right basically near this downtown London, but that's kind of cool. So if you ever get to London, or maybe you've been, besides visiting Big Ben and what's the big Ferris wheel, the Eye, or whatever it's called, you can also go visit the Royal Observatory. So right there, you'd be standing on the prime meridian, which is kind of cool. We spin opposite the sun, right? The sun rises in the east over here, and the sun sets in the west. That's because we rotate from west to east. So this yellow arrow shows our rotation direction. Right? If you look at any globes, you'll see right along the equator, they'll put an arrow and they'll say direction of rotation. So we spin west to east. We go in the east direction. That's why people to the east see the sun first. Right? We are on the East Coast, New York. We see the sun rise 3 hours before California. California's to the west. So people in the east see the sunrise before people to the west, right? So even England, right? England is what I believe 5 hours ahead of us. So take whatever time it is at your house and add 5 hours, and that'll tell you the time in England, right? It's always going to be 5 hours ahead of us, England. But yeah, we spin west to east. So east sees the sun before west sees the sun. I always say east is later in the day, right? So east is later in the day, west is earlier in the day. California is always 3 hours earlier. If you watch television, a lot of times when they run commercials and those shows coming on prime time, right? Prime time is what time? 8 o'clock, 8 p.m. So they'll say 8 p.m. east, 5 p.m. west, right? California 3 hours behind us. So we are always going to be later in the day. It's 8 p.m. versus earlier in the day, California. So longitude's a little different. Latitude, again, you remember, uses Polaris, and whatever Polaris's angle is your latitude. Longitude uses the sun, which is also a star. So they both use star angles. Polaris is used for latitude, and the sun is used for longitude. This is a little trickier, so let me go through the steps here to find your longitude. So you have to first know the rate of rotation. So again, we spin west to east, and we spin every 24 hours, right? 24 hours is a day, and every rotation, right? Again, if you're looking down on the Earth, let's say that's the North Pole, right at the top. So we're going west to east. We're spinning counterclockwise if you're looking down on top of the Earth, is 360, right? We have to make a 360-degree rotation, that's a day, in 24 hours. If you take this 360 degrees and you divide it by 24 hours, where's my calculator? 360 divided by 24 hours in a day, you get what I call the magic number, 15. So that means, let me clear that. That means we rotate 15 degrees an hour. That's our rate of rotation. 15 degrees every hour the Earth is rotating, west to east, 15 degrees an hour. You need that number when you're trying to figure out your longitude. So remember that number, 15. So to get your longitude, the first thing you need to know is how many hours, what they call the solar time, or even just clock time. What's the time difference, how many hours between you and the prime meridian, which is in Greenwich, England. So again, New York is where we are, Rhinebeck. We are 5 hours difference between us and England. So that would be step one. How many hours between you and the prime meridian in Greenwich? We're 5 hours. Second step is multiply that hours by 15, right? Because again, the Earth is moving at a 15 degrees per hour rate. So you would take that 5 hours that we are from England, multiply that by 15, and if you do that, you get 75 degrees, 5 times 15. Now, the third step is probably the trickiest, and that's why I was referring back to that. Let me go back. This whole west to east thing. So again, because we rotate toward the east, right? This is east over here, and this is west over here. East, again, is always later in the day. If you are later in the day than England, you are to the east. If you're earlier in the day than England, you are to the west. And that's where that third step comes in. If your time is earlier than England, than Greenwich, you are to the west. We are earlier than England, so we are west longitude. If you are later in the day than England, you are to the east, right? And the way I try to remember that is California and New York, right? And this is going to be a horrible diagram, especially a picture drawing with a mouse. There's Texas, Florida. But you get the idea. That's supposed to represent the United States. So New York's over here. LA's over here. We are on the East Coast. California's on the West Coast. And again, we're rotating this way. So because of that, we are 1, 2, 3. We're 3 hours ahead. Hour. 3 hours ahead of California. So if it's, again, 8 p.m. in New York, this is 7 p.m., 6 p.m., 5 p.m. It's only 5 p.m. in California. So we are to the east. We are later in the day. So later in the day, you're to the east, earlier in the day to the west. Now, if we compare not New York and LA, but using Greenwich, right, England, we are earlier than England. We're always 5 hours earlier than Greenwich. We are always to the west. So it's 5 times the 15 gave us 75. And because we are earlier than England, we are to the west. So our longitude would be about roughly 75 degrees west longitude. Let's do some examples here. So the prime meridian is actually right here, right on this spot here. And the time of day is noon. Solar noon, which we'll get into, is basically when the sun is at its highest angle for the day. But on a clock, we'll call it 12 o'clock noon. I've got B over here at 10 a.m. I've got A at 7 a.m. C is at 2 p.m. D is at 6 p.m. And I put the Earth's spin down here. We're moving, again, west to east. We're heading this way, toward the east. So noon at the prime meridian. They want the longitude for A, B, C, D. So we'll start with A. I find, again, go through the 3 steps. I find the difference in time between the prime meridian and your location. Well, it's noon at the prime meridian. It's 7 a.m. at your location. So how many hours in between? So I do 7. Never count 7. You go 7 to 8. Right? That's an hour. 9, 10, 11, noon, 12. That's 1, 2, 3, 4, 5. I'm 5 hours difference between 7 and noon. I then multiply 5 times 15. I get my 75 degrees. And again, A is earlier in the day, right? Because noon is later, 7 a.m. is earlier. That means A would be 75 degrees to the west. Let's look at B. B is 10 a.m. So I say, all right, how many hours between 10 and noon? That's 2 hours. I do my multiplication, 2 times 15. That gives me 30 degrees. And again, 10 a.m. is earlier than noon. So again, I am to the west. So I'm 30 degrees west. Now I look at C, 2 p.m. That's still 2 hours, right? So it's still going to be 30, but this time, what is 2 p.m. compared to noon? Oh, that's later in the day. Again, later means east, right? East. So I'm moving to the east. C would be 30 degrees east. And then D is 6 p.m. So noon to 6 p.m. You count 1 o'clock, 2 o'clock, 3, 4, 5, 6. That's 6 hours. 6 times 15 is what? 90. And again, you're 6 p.m. You're standing at D, but the prime meridian is back here at noon. So you are later in the day, just like the East Coast is later than the West Coast. So you are 90 degrees to the east. So anything on this side, the 7 a.m. and the 10 a.m. is to the west. And if you're to the right of noon, to the right of the prime meridian, you are to the east. It says, what is your longitude if it's noon at your location, 10 a.m. at the prime meridian? So again, the first step is find the hours. Well, between noon and 10 a.m., that's 2 hours. You then multiply. 2 times 15 is 30. That means you are 30 degrees. Now, let's see. You're you're noon, and the prime meridian's 10 a.m. So you are actually what? Later in the day, right? Noon is later than 10 a.m. So you're later in the day. That means you are to the east. Later's east. And therefore, you are at 30 degrees east longitude. Let's do a couple more. It's 6 p.m. in Greenwich and noon at your location. What's your longitude? So again, first find the hours between them. 6 p.m. to noon is 6 hours. You multiply by that magic number, 15. 6 times 15 is 90. And again, where are you? You are at noon, and it's 6 p.m. at the prime meridian. So you are actually earlier in the day, right? California's earlier than New York, so you are on the west coast. So you are 90 degrees west, right? Earlier in the day, because you're at noon, is west, 90 west. A couple more. It's 8 a.m. in Greenwich and 3 p.m. where you are. So 8 a.m. to 3 p.m. So that's 9 a.m., 10, 11, 12, 1, 2, 3. That's 1, 2, 3, 4, 5, 6, 7. You're 7 hours different, right? times 15. 7 times 15 is, what is that, 105? If I'm doing the math right, 105. And you are 3 p.m., so you're later than 8 a.m. Later in the day, right? You're heading to the east, so you would be 105 degrees east. Good. And 2 a.m., your location, noon in Greenwich, so 2 a.m. to noon, that's 3 a.m., 4, 5, 6, 7, 8, 9, 10, 11, 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You're 10 hours. 10 times 15 is 150. So you're 150 degrees. And you are earlier in the day, right? 2 a.m. is way earlier than noon. So California, you're going west. So it'd be 150 degrees west longitude. This was on a region. So letters A, B, C, D, X on the map below represent locations on Earth. The map shows a latitude, longitude grid. Remember, lat, flat. So the numbers that are latitude are the flat lines, which means the 30, 60 south, the 0, the 30 north, 60 north. Those are your lat. I don't want that right now. I'm looking at the longitudes. Solar time, as soon as they talk about the sun, solar, you're talking longitude. L-O-N-G, longitude, is based on the position of the sun. If it is 1 p.m. at X, at which location is it 5 p.m.? So I know it's 1 o'clock at X. I'm looking for where it's 5 p.m. So what I like to do is I go right up to the map. And on a regions, right on the question. Put your right on it. So I know at X it's 1 p.m. Then I have to think about the steps again. How many hours is it from 1 p.m. to 5 p.m., right? You would do 5 minus 1. That's 4 hours. Then I say, okay, 4 times 15, right? Because it's 15 degrees rotation per hour. 4 hours difference times 15 gives me 60 degrees. Then I look at which way I'm going. If it's 1 o'clock at X, they want to know where it's 5 p.m. Well, what is 5 p.m. compared to 1 p.m.? Well, 5 p.m. is later in the day. Later in the day means you're going to the east. You're going this way, to the right. So you want to go later from X. You want to go east. I want to go how many degrees? Well, I figured that out. 60. So now I look at the longitude number for X. And this is where it gets a little tricky. I look at X. I go straight up. Notice the longitude for X is 150. And I also notice that when I head east, right, I'm heading toward the prime meridian. My numbers are actually decreasing because I'm heading back to England, heading towards 0. So I need to say, okay, I don't want to add 60 to 150. You want to subtract this 60 from this 150 because you see how your numbers are decreasing. So you'd say, okay, what's 150 minus 60? And again, you have a calculator if you need it, but that ends up being 90 degrees. Then I now go over to 90 and I look down the 90 line and I'm looking for a location. There it is, letter B, which is my answer. Now what makes this a little tricky is these numbers. Some maps, they're going to try to fool you. Notice the number of degrees between each longitude line. This is 150, this is 120. That's 30 degrees, right? The next number over is 90, that's 30. 90 to 60 is 30. So they drew longitude lines every 30 degrees. Well, if you use that rate, the rate was 15 an hour, that means between each of these longitude lines you have how many hours? 2, not 1. So from here to here is 2 hours, from here to here is 4 hours, from here to here is 6 hours. So that's another way of looking at it. You said, all right, I'm 4 hours difference, right, between 1 p.m. and 5 p.m. If you know it's 15 an hour and you could see, oh, this is 30 degrees, that's 2 hours in between, and I have to go 4 hours, I know I got to go 2 hours here and another 2 hours here. So that's how that'll get me over to the 90 every 2 hours. But what's going to be tricky on a Regents, and I caution you, sometimes these numbers are not counting 30s, they'll do 15. So this might be 150. This one over here might be 135. This might be 120. This might be 105. They might use 15 degree lines, not 30. So you gotta just watch. I tell kids, be careful. Always look at the scale they're using for longitude. Are they counting by 15s? Or are they counting by 30s? Because they're going to try to mix it up a little bit. And they want to make sure that you're paying attention. And they're going to try to trick you. So just be careful of the degrees there. How many hours each? Some kids will just assume, oh, well, between each line, it must be an hour. Well, in this case, it wasn't. It was 2 hours in between each longitude, not 1. So just be careful. This one here. So you can see a little different if I look at the scales, right? From the equator to 10 degrees, these are 10 degrees between latitude. Notice the longitude. So here they didn't do 30 degrees. They actually did 10, right? 70 west, 80 west, 90 west. It's only 10 degrees, right? That's not even an hour. But anyway, let's look at these two questions. It says, what is the angle of Polaris above the horizon for person A? As soon as you see Polaris, that's not a longitude question. That's a latitude question. So you're looking at lat. So that means I have to use my lat flat rule. So flat lines are here. Boom, boom, boom. What's my numbers? 10 south, equator, 10 north. Well, this says what's the altitude of Polaris for A? Well, A is right here. I'm using latitude. I come across. Lat flat. What's my latitude? 10 degrees. That's my answer. But what will happen on a Regents is, again, you got to know your lat versus your longe, because a kid will say, oh, well, A's right here. Oh, the latitude must be 90 because that's the closest number just sitting next to letter A. And they'll say, oh, it must be 90, and see how they give you that as a choice. But that's not correct, because I want latitude, lat flat. These are my latitude numbers, the 10, not the 90. That's my longitude. So I'm going with 2. 2 is the correct answer. This one, which two people, observers, people, same thing, would be experiencing the same solar time? Who's on the same now? We're talking sun, so we're talking longitude. I want the two locations that are on the same longitude. Like, for example, New York City and Miami. Yes, we're in different states, but we are, for the most part, vertically along the eastern seaboard. We have the same time, right? If it's noon in New York, it's also noon in Miami. Whatever time it is here, it's all the same up and down vertically the eastern coast. So in this case, I want two places that are vertically up and down the same. Well, A and C, nope, because C diagonal. B and C, nope, that's horizontal. That doesn't work. B and E, that works. D and E doesn't work horizontal. So B and E would be my correct answer because they are on the same longitude. They're both at 80 west. So any place on this line would have the same solar time or time. Same thing. Zulu. So this is military. Would use Zulu time. I just threw this in there as extra kind of information. So Zulu is is that which was most commonly known as GMT. So sometimes you'll see on a computer or a clock, it'll say GMT. GMT stands for Greenwich Mean Time. Our natural concept of time is linked to the rotation of the Earth, as we talked about. We define the length of a day as 24 hours, on average, that the Earth spins once on its axis. As timepieces became more accurate and communication became global, there needed to be a point from which all of the world times are based. Since Great Britain, England, was the world's foremost maritime power, right, navy, they had a very strong navy, when the concept of latitude-longitude came to be, the starting point for designated longitude was the prime meridian, which is 0 degrees and runs through the Royal Observatory in Greenwich, England, which we talked about. When the concept of time zones was introduced, the starting point for calculating different time zones was agreed to by the Royal Greenwich Observatory. Unfortunately, the Earth does not rotate at exactly a constant rate. Due to various scientific reasons and increased accuracy in measuring the Earth's rotation, a new time scale called Coordinated Universal Time, or UTC. You'll see that often. It's written backwards. Well, the letters are different in the way you say it. So it's the C comes first. It's Coordinated Universal Time, but it's written UTC, has been adopted and replaces the term GMT. The Navy, as well as civil aviation, your military, uses Z, phonetically Zulu, to refer to the time at the prime meridian. NOAA satellites, NOAA is your weather, National Oceanic and Atmospheric Administration. So your weather satellites use Zulu time or UTC as their time reference. The satellite images that appear on NOAA's website will have a Zulu time stamped on them. The Navy, actually, if this ever comes up on a trivia question, Jeopardy, the Navy serves as the United States official timekeeper. And we have actually there, and I've been down there many times. You go to Washington, D.C., there is actually a master clock. It's down at the U.S. Navy Observatory. It's in D.C., so you can see the official timekeeping device, which is through the Department of the Navy, and it's down at the Navy Observatory in Washington, D.C. So if I click on this when I have these little globes, these are like YouTube clips and links, websites. So if I click on this, and I'm making this video 1:30 on Sunday, so you can see this is UTC, Zulu time, or Prime Meridian time. So it tells you Zulu time zone, UTC, that's your coordinated universal time. Longitude is 0. That is the time at the Prime Meridian. 1700. So they use military, which would be, what, 2:38. Well, no, sorry. Wouldn't be 2:38. It'd be 5:38. Yeah. 5:38. So they're 4 hours ahead of us. Sorry, messed that up. So they're right. We're at. I'm looking at my clock on my computer. 1:38, which is 13, right? 1300 hours. 13:38, and it's 17:38 in England. So we are 4 hours right now. You might say, "Well, Mr. Rock, I thought you said we were 5." The reason is Zulu time does not take into account daylight savings. And that's because today being October 18th, we're still in daylight savings time. If you recall, in the spring, we spring ahead. So we are only 4 hours away from Zulu time, from the Prime Meridian. But once we turn the clocks back, which will be in another couple weeks, then we will be 5 hours. And you see it says it actually down here. Zulu military time is a fixed time that never observes daylight savings. So see, we're 4 hours, well, it says Hyde Park, but I'm in Rhinebeck. So we're 4 hours difference. But if I check this in a couple weeks when we change the clocks back, we'll be 5 hours different from Zulu time. Yeah, they don't observe daylight savings. We do. So right now we're 4 hours different from Zulu. But you can always go to this military time zone thing. It'll tell you what is the time in England. Of course, you have on your iPhones, and you can always look for, you go into clock, and it'll give you times different parts of the world. Or you can ask your devices in the house. I won't say it because I have an echo in my room, so I don't want to say that. It starts going off. You know what I'm talking about. The one that starts with an A. Okay. I try not to say your name too much. And I went over this. So this was the same thing when I went and go back and watch the video on latitude. If you haven't, longitude works the same way. So if you had, again, I'll just refer, let's say I had 2 longitude lines, and this is 73 degrees west, and this is 74 degrees west, and I have an X right here. It's halfway. You could write it 73.5 west. You could say 73.5 with a fraction, or then you go into those minutes. 60 minutes equals a degree. So because I'm halfway between 73 and 74, I'm going to write 73 degrees, and I think of a half an hour, right? 60 minutes is an hour. In this case, we're using degrees, same thing. So it's going to be 73 degrees and 30, think of half a degree, minutes west. Do you have to write the 00 for seconds? Not necessarily. You could just write it in this way. You would not really use seconds unless you were like zoomed in on, like I said, street level, or a very, very detailed, accurate map that was down to like people's houses or something like that. But you could just use, minutes. It's fine. You don't have to go down necessarily to seconds. Anyway, that's how you do that. So go back and watch the latitude video if you need more help on that. This is something we're going to be getting into pretty soon. This is called a topographic map. The first 3 letters spell the word top. You're looking at land and elevations, mountains and valleys and things, but you're using a bird's eye view. All of these lines on here are called topographic lines, contour lines, and they show elevation. And what you're looking at here, these are maps. They call them quadrangles. This is out in California, this particular map. But I just wanted to point out that on these maps that show mountains and elevations and stuff, they're called topographic, they put the latitude, longitude coordinates in the corners here. So you can see, for example, right in this corner, the latitude is written right here. It's 37 degrees. There's those minutes, 37 minutes and 30 seconds north, right in this corner. And then the longitude is 121 degrees and 30 minutes west. And then what you would do is if you wanted to see how the minutes change. So right here, it's 121 and 30 minutes. Right here where this dash is 32 minutes. So it'd still be the same degrees. You would say 121 degrees and 32 minutes. Then I go this way, 121 and 31 minutes. So I'm going lower in the minutes. Same thing when you're looking at latitude. They're going to put the minutes as you go up and down the chart, down the map. This we did, again, you should have done in the latitude video, so if you haven't watched that, is add some grids to that. I just threw a question on here real quick. Here's one. So this is off of Regents. Base your answers to question 36 through 39, which I didn't give you 36, 37. I just took out and went right to 39. On the graph below in your knowledge of Earth science, the graph shows observed water levels for a tide gauge located at Montauk, New York, on the easternmost end of Long Island. January 24th, 2008 to noon, January 25th, 2008. So you're looking at ocean tides. Remember, every 12 and a half hours is your high tides, cyclic, right, repeats. But the key here was, and you had to read this part, and I tell kids, when you go to look at a Regents question, a lot of kids will just jump right down here and look at the question. You don't want to do that. You want to actually read these little intros. And again, for those of you that come to class, you might have heard me say this, but for those of you that are remote only, I write questions for the Regents. I don't know if I ever mentioned that to you. I might not have. So I actually work for State Ed and write Regents questions. It's kind of fun. I've been doing it for about 6-7 years. So when we write questions, well, I'm one of probably 10 Earth science teachers around the state that write these questions. We put an intro. Sometimes the answer is actually going to come from the paragraph, not necessarily from the graph. So in this case, it said, what is the approximate latitude and longitude of the tidal gauge? Well, a student might go, I don't know what they're talking about. You got to read this stuff up here because it told you where it is. Montauk, New York, and it told you where Montauk is. Eastern end of Long Island, right on the tip. So that means you're going to go back to your map on page 3, and I'll leave this here. This is on page 3 in your ESRT. The easternmost tip is way out here, right? Now I look at my latitude, lat flat. Right, so what's my lat? 41. What's my longe? Well, this is 73. This was 74. So 74, 73. Right, I'm getting closer to the prime meridian. I'm going that way. So right on the tip, 72. So I've got 41 north. I've got 72 west. That's my longitude. And then I go back to my choices. Right, I had 40 and a half, right, because there's 30, 72. 40 and a half, 74. Here's my 41, 72 west. So I would pick 3 for that one. 3 would be a correct answer because that's right on the tip of Long Island. But again, if a student didn't know what they were talking about, where's the tide gauge? Up here, it tells you where it is, Montauk, and then it even gave you where is Montauk, right on the eastern end of Long Island, which is right on that tip right there. And so that's how you approach that kind of question. Okay, that's it for this video. This is the second one for the week. I will be making one more video. Again, watch these videos carefully, pause, rewind, go back, parts that don't make sense, but use the videos, because these are my lessons, use these videos to help you with the homeworks, okay, because that's where I put all this information into my recordings and to try to give you help if something doesn't make sense in a homework sheet. Okay, talk to you soon. Bye.